Thank you for the introduction. We will start by talking about open science, because the introduction was sufficient. Well, generally, open science is quite a broad term. We will not talk about everything that regards open science today. We will just pick some of the topics that may be more interesting for you. Let's start with the broad definition anyway. Open science is the practice of science in such way that others can collaborate, contribute, and where research data, lab notes, and other research processes are freely available under terms that enable reuse, redistribution, and reproduction of the research and its underlying data and methods, which is kind of mouthful definition by Foster Open Science, which is a very interesting site that works on that helps with teaching about open science. We can see if we just choose some of the words that may be interesting and important for your work. You can see that open science is a practice of science in such a way. It's not like one specific thing. It's a way of doing things differently, so you can collaborate and contribute, and where your research processes are freely available for the others, and you enable reusing, redistribution, and reproduction of the research and its underlying data and methods. It may be slightly different in some fields from the practice that was used to be when main focus is on the publication itself. In open science, it's considered to be wider thing, the publication of the methods and data. We can see in open science taxonomy all the things that are considered to be part of the open science. You can see the main topics are open access, open data, open reproducible research, open science evaluation, open science policies, and open science tools. It's really quite a lot of things to talk about. So we will today talk mostly about open data and partly about open reproducible research. Open science influence on the research process is quite wide. It's not only about publishing results. The changes are possible in different phases of research process, and you may think about it if it's something that would work for you, or if it makes sense in your field. We can look on more specific examples. You can see there are some things that can be considered during creation of a hypothesis. You can change something in data collection, in processing, for example, with the using of open software or open source software. You can store your data and results in a different way. You may describe them more. You may think about long-term preservation, and enable your data to be found even after a few years. The publication, of course, is different, because now you should publish not only the article but also the data and methods. So you may be able to publish a whole process of your work. And of course, there is some part of reuse, when you can reuse data from other sources, which may be it's considered to be an important part to reuse data from different sources than your own, because when you have some data sets that can be analyzed in different ways, and you will just use one way, there is still possibility that somebody else can use it for something slightly different. So that's the part for general open science introduction. Now we can talk a bit more about reproducibility. Reproducibility and replicability are two terms that are difficult to say, but and they are quite complicated explain. Reproducibility is research, when research data and code are made available, so the others are able to reach the same results as are claimed in some specific scientific outputs. This is the easiest way, I would say, if you describe your product or your research data in such a way that somebody else can come and use it, really check if what you did really holds, and if you didn't do any errors. Replicability, on the other hand, is repeating a scientific methodology to reach similar conclusions. This is probably more complicated in some fields, because really establishing the same environment may be complicated, and it's many problems with replicability are coming from this problem. There's an interesting article about reproducibility crisis. When Nature asked 1,500 scientists what do they think about the reproducibility in their field. The questions were, if there is a reproducibility crisis, how much published work in the field is reproducible? If you have tried and failed to reproduce an experiment done by somebody else, if you ever tried to publish a reproduction attempt, which I think it's not really common at the moment. Have you established any procedures for reproducibility? I can tell you that chemists and physicists have highest confidence in reproducibility in their field. It's slightly worse in natural sciences and medicine. But I think that well, it's in the process how publishing works at the moment. It's not very simple to try to find time and energy and money to reproduce someone else's results, but it would be probably a good idea to check the results that are published a bit more. So in physics, it's kind of possible to achieve some reproducibility. So let's look on some tips for what you can do to improve reproducibility of your results. Sorry. So firstly, plan for reproducibility before you start. You can create a study plan or protocol. You can choose reproducible tools and materials and set up a reproducible project. You will probably do these things in similar way. You just will try to think about these specific things and keep them in mind. Other thing is keep track of things. You can pre-register important study design and analysis information. We will put the information about the study you are going to conclude in some system that's used for it, and you will see if when you do everything you planned, if the result will confirm your hypothesis or not. But if you will do everything correctly, it will be still important information, even that you didn't achieve your expected results. Use version control. For example, for software, you need to know which data were analyzed by which version of the software, because there may be some little changes and you can get different results. Document things, write documentation. It's really painful process sometimes to keep everything documented, but when the number and amount of your research products grow, it's hard and complicated sometimes to get back to results that were from a few months ago. So documentation, even for yourself, should help. Another part is sharing and licensing your research data, materials, software, notebooks, and containers. Licenses are important because you let know people what can they really do with your material. Generally, if you don't put any license on things, it may be just generally protected by law in some way. So it may cause the problems. You may not really decide you will try to enforce the law protection you have on your work by default, but still somebody will try to work with your data and your things. They will be probably much more happy if they will know from the beginning that the things they are doing are okay. So licensing and providing information about reuse is important. And last point is report your research transparently. Report and publish methods and interventions explicitly, post results to registration platform. So the transparency is important part. Well, it may happen, of course, that you will do some mistake, but then it's still probably better from the point of general knowledge when somebody will know that there was some mistake, then if they will consider some results to be okay and they are not able to check them. So this is part about reproducibility. Let's start talking about data. I don't know if you know the term fair data. It's not really widely used at the moment in the Czech Republic, I guess. I think it may be different in Germany. I would hope so, because this term is starting to be very important. Fair data is acronym for 4 words: findable, accessible, interoperable, and reusable. It's a buzzword to some extent. It's widely used in EU materials, for example, in Horizon 2020 and Future Horizon Europe project. It's used regarding large infrastructure like EOSC, European Open Science Cloud, where the goal is to have all data fair. It, as you see in this point, it doesn't really mean that all data has to be open, because this is complicated in some fields. For example, when they are working with human subjects. But it means that really it should fulfill the FAIR principles. Openness is welcomed, of course. It's a great thing to have if it's possible, but sometimes it really is not. And you really shouldn't look on this in a way that, okay, I can't open my data, so I should ignore FAIR. That wouldn't be a correct decision. The term was coined in 2015, and it describes some features that the data should have. And we have recently talked to a guy who was in the group that coined the term, and he told us that the original idea was the analogy of the airport. When you have different services, everybody is doing their thing, but it all together works as an organism. So you create an environment where you know how to communicate. I don't know, airlines are somehow connected with the process of people getting into the airplane. You have this part behind the gates, and you still have. You've been all probably on airports, probably not recently, but anyway. And you have an idea that all airports are similar. You can expect some kinds of services. The providers differ, but it works. So that was the original idea. Now for the 4 points. Fair data, findable. Of course, it's necessary to have possibility to find the data. This one is closest to the library word, and you can see the persistent identifiers, which is things that librarians like, and metadata, which are data that describe something, is another thing that librarians like. One thing that's kind of new in this is that it should be findable for both humans and computers, because you should be able to process. You shouldn't really do it as a service like some website where you just you expect that your colleague will come and type some words and use some service and get data, but also computers should be able to get some information and process it on some level. But it's connected with the next points. I think it's important to notice a bit more persistent identifiers. You probably know them from different aspects of your work. You may know DOI for journals, or you can know ORCID or researcher ID for people. The problem is, as you can probably tell from experience with some identification of persons, you can, if you are in a specific context, you know who somebody Jan Novak is. But if you are in the World Wide Web, there may be many people with the same name, so you need some different system how to describe or identify the people. It's similar with people, it's similar with articles, and it's similar with the data sets as well. So if you will be publishing your data somewhere, try to check if it will get some persistent identifier, because it's one of the most important things in being fair or having the data fair. Metadata for describing the data sets are important as well. There are right ways how to create metadata descriptions. You may ask your librarians who are describing books of all kinds in a way that they can be found in the library, hopefully. The trick is to use words and descriptions that the person who will be looking for your research would use. So important are, for example, vocabularies, because if you will use some terms that nobody knows and nobody uses, they won't find your work really. So accessible, it's kind of more simple. Data and metadata should be retrievable by their identifier. Using standardized and open communications protocol. Still, as I mentioned, authentication and authorization is possible. Not everything has to be open, but metadata should be open, openly available. This is kind of straightforward. Don't hide your data if you don't have to. Interoperable. So it should be possible to combine data with other data or tools. Format should be open or and interoperable for various tools. It may be a problem if you have some specific device, for example, that generates data in format that is specific for some software that's used for processing the results, and then you will get some kind of graph, for example. So still, if you will try to publish your data, you should do it, if possible, in some way that should be able, when there should be possible to analyze it with different tools. It works, or it same thing should be for metadata, where you can use some vocabularies, but again, this is more. Vocabularies means that you have some set of terms that you are using, and you are not really creating your own terms, especially when there is some dictionary or vocabulary or thesaurus in your area. You should really stick to these words that are used for this, and not try to be too creative, because then nobody will use your created terms, and nobody will find anything, or anything. They won't find your data set. And the reusable is the last point. It should be your goal to optimize data for reuse. You should describe the data sufficiently to allow replication of results or reuse in different contexts. And you should use the license, as I mentioned. I would describe it like try to have a look on your data from outside. If you will just find a data set you just put into the repository and you will just see it for the first time, would you understand what is it about? Or is there something that should be added? So FAIR principles are described to more depth on the web page gofair.org. You can see them on the generally the specification by points is the thing on the slide, but I try to talk like more generally about what does it mean, and what was the intention of keeping things fair. So that's for FAIR data. Now I will shortly mention data management plans. Again, this is something that's not widely used in Czech Republic yet, but it's very likely that it will be more common in the future. Data management plan is a document that specifies what data will be created and how, and outlines the plans for sharing and preservation of the data. So this is document that is describing what you will do with your research, what you expect your results and outcomes in the terms of data, what do you expect them to be, what do you plan to do with them, how we will store them, how we will collect them, how we will document them, and everything. You can see the main points here. Again, that's important to know, for example, what data will be collected or generated, and how we will be storing them, how was the information necessary for interpreting the data, what about storage and long-term preservation. It may be mandatory from some projects to keep your data for a long time, or maybe sometime at least describe why you don't want to keep them for a long time. And you should also mention some responsibilities and resources that you need, because but for example, in imaging, when you create a large amounts of data every day, the thinking and planning of what will you do with your data is very important, because then you run out of space very quickly and you can't really do much about it. So the goals, why should you create data management plans? We have a few points which we consider important. It helps you, if you go through such plan, it's kind of checklist. It helps you anticipate potential issues. What will you need? What you have? What you don't have? It will decrease the risk of duplication of work, data loss, or data security breach. You know, when you really, you will have to think twice about it if you want to keep all your data on your USB stick and said, okay, this is the way how I secure my data, and I hope my kids don't find it. It's helping you ensure that the data are complete, accurate, and reliable. So you have everything a bit more under control. You can ensure continuity and consistency in long-term projects. It's mostly when you have larger teams, when people come and go, you need some consistency in working with data as well, because then you will try to get more information from somebody who is already on a different institution, and it makes things more complicated, and it's not even good for them, because their results are kind of, it's more likely they will go to waste if nobody will be able to use them. And then you can save some time and energy when searching the data, writing up papers. When you are asked to do something more with your data, you need to have everything like under control to be able to assess these problems with less energy. And it helps you also to prepare your data for sharing, because you will know or you will think about why you want to share this and why you would like to share something else. Another thing is, and the last thing is meeting the requirements set out by research funders and publishers. This is an example of how this thing really is coming alive, because it will be probably in a few years necessary and mandatory to create some form of data management planning for the project. At the moment, for example, in Horizon project, you will have to, or ERC, you will have to submit your data management plan after six months. The DMP isn't really like static. It's not like the project itself where it's really difficult to change anything. It's living document, and you should be able to modify things. But the main goal really is to show you what are all the things that you should keep in your mind. And the other part is that you should be able to work with the data more efficiently. There are some tools that are for where you can look at how data management plans look like. Still, for the Charles University, we don't have any template for our data management plan, but it's planned. Generally, the mostly used service is DMP Online, which is international website where people can create their own data management plans, but many institutions have their own instances of this system. So there are many more systems like this. You can create your account and you can pick the data management plan template. This is generally the questions that your founder, for example, would ask you about your data, and you can fill it in some form. So if you are interested in this, you can for sure check this website. And we are coming to open research data, and I will give the word to my colleague Dagmar Hanzlikova.
Good morning, everyone. I will talk to you about open research data following on the data management plans, because the idea behind managing your data and making your data fair is ultimately that you can open your data so that other people can use it and check your results, or possibly come up with new ideas what to do with your data and do new research on your data. So when talking about open research data, what it is, open research data are data that are freely available to anyone and can be used, modified and shared for any purpose. Of course, opening research data does not necessarily mean that all your data should be freely accessible and freely available to anyone, because in some cases, sharing is not possible at all. For example, there is some personal data protection or intellectual property rights, and you cannot share this kind of data. So the general idea behind sharing data is that data should be as open as possible, as closed as necessary. That means that you open as much of your data as you can, but at the same time allowing that some of your data cannot be shared, or there may be some restrictions on sharing the data, and you may only share a subset of data and not everything that you have. why should you do that? Why should you share data? So of course, one of the reasons why you should share the data may be that you have to do it because it's the research funders policy. For example, in the Horizon 2020 or some European Union research grants, it is mandatory that you share the data, again, under the policy of as open as possible, as closed as necessary. Some national funders joined the effort in opening data, so especially in the UK. I'm not sure how it is in Germany, not so much in the Czech Republic, but there is the EU directive on open data that will require, it is currently in the Czech Republic, it is currently being implemented. In Germany, I don't know if it already is or if it will be implemented at some point, but it generally will require funders to demand that data are managed, ultimately open, but in the first stage, the data should be managed. And the way they're going to do it is possibly by requiring a data management plan that Milan was talking about before. And ultimately, they may require you to open the data as well. It is also increasingly common that journals or publishers require open data, that you made available the underlying data of your research for the purposes that other people can replicate your results and verify that what you did is actually based on like real data, and that you just didn't make up the results. Apart from, even if you don't have to, there are still good reasons why you should share your data. There are benefits in it for researchers as well as for the wider society. As for the benefits for researchers, opening your research data boosts the robustness of your research as it allows others to replicate the results. Related to that is that it enhances your reputation and as an honest and careful researcher, and so increasing your impact, possibly. It may increase your citation rate as well, because if you publish your data openly, you add the persistent identifier to your data, then other people will be able to cite your data, so that will count the citations as well. Plus, some research suggests that sharing your research data may actually increase the citation rate of the associated publication as well. And of course, compliance with funders and publishers' policies, as we've mentioned partly before. But there are also benefits for wider society. First of all, it comes to the effective use of resources, because if it's public money, most of the research or a lot of the research is funded from public money. So that way, if you share your data, then the data that was created once already doesn't have to be recreated again by someone else who wants to do similar research or who want to research a similar problem and would use your data. Sharing research data may speed up the research process as well. You can think of the COVID pandemic right now, because there are researchers all over the world working on the problem, sharing their data, sharing their results. If they didn't do it, it would probably take much longer to actually know anything about the virus, to do anything about the pandemic, about the epidemic at all. Sharing your data may also encourage citizen science. So people, even though they're not researchers as such, they may still want to help out, they may want to do something. I know a beautiful example is from a birding society. So people help spot various kinds of birds, which helps researchers to estimate their population or follow the patterns of how they migrate and stuff like that, just because people are helping them and they're excited about the project. And finally, of course, by sharing your data, there is a reduced possibility of academic fraud. We all hope that researchers are honest and nice people, but they're still humans. So there may be people, especially with the huge pressure on the publish or perish model, and journals often publishing positive results only. There may be a huge pressure on researchers to tweak their data so that they would get the positive results that the journals want. So if you share your data that you've measured, you reduce the possibility of academic fraud, and it links to enhancing your reputation as the honest researcher. So which data should you share? Generally, the idea is that you should share everything that is needed to replicate your study. That can be underlying data, so some measurements that you took. It's maybe software or code that you use for analyzing the data. It's maybe a lab protocol or some code books, so that other people can understand what your data actually mean. When deciding what data to share, you also need to keep in mind that some data may not be shared at all, as we mentioned before, due to data protection, personal data protection, intellectual property rights. There may be other issues. So keep ethics and legal issues in mind. If you're using some third-party data, there may be under copyright that doesn't allow sharing the data further. So you need to keep that in mind. Also, you may not be the only person who decides which data will be made available, especially if you work in a team. There may be other people in the team that will have a say in what data are being shared or not. Funders and publishers may require that some particular type of data will be shared. So, for example, usually if it's a funder, they may demand that all data that you've created as part of the funded project should be made available, whether you've made a publication of it or not. But we gave you money to do this research, so we want the results. We want all of the results to be publicly available. Also, if you work with human participants, which is probably not so much of a case in physics, but who knows, maybe there might be some surveys or something, then the participants will need to give you their informed consent that they're happy that you're analyzing and sharing their data. So these are just things that you need to keep in mind before sharing. You also need to decide who do you share your data with. Is it okay to make it public for everyone, or should there be some restrictions, for example, only for people from your organization, or who else should or may have access to your data? You don't have to share the data immediately. Usually, even publishers and funders will allow some embargo periods. So, for example, if you don't want to share your data straight away, or there's some research, you've got another project that analyzes the same data, very often they would allow you some embargo period, usually about 6 or 12 months, so that you can finish the research that you're doing, you can finish the project, and then share the data at the end. But usually they will make you think of the embargo period and set it like, you publish the results, you publish your publication and say, okay, 6 months from now, I will share the data. Often the case is that they will require you to upload the data in a public repository first with an embargo period, so that they know that the data is already safely stored somewhere, but they may not share the data straight away, but allow you that it is made public, for example, after half a year or a year. Okay, so how do you share the data? How do you do that? One of the ways, of course, is that data can be shared as supplementary materials to research articles if the journals allow such option. This may be appropriate if it's something smaller, like a small spreadsheet with some values, but in general, it is not recommended to use the journal supplementary materials, unless the publication is open access. Because if you share the data as supplementary materials to a published article, then very often the copyright on the data may be transferred to the publisher. So unless you want to give your data over to the publisher, it's better to use some alternative way. Such an alternative way may be a public repository or data journals. Data repository can be subject specific or general purpose. It is mostly recommended that if you can, you should publish your data in a subject specific repository. Those are repositories that specialize in sharing some kind of data. So there may be, I don't know, some linguistics repositories that will focus on linguists related data. There's also going to be some repositories focusing on data and in the area of physics. And one way to find these is through the portal read3data.org. When you go to the website, you can enter keywords and look at the entries that it finds. You can read a short summary of the repository that you found. You can look at the repository to see if the data sets that are shared in that repository look relevant to you, if they look like it is something that is relevant to your data as well. Using the subject-specific repository also means that if you want to browse the repository yourself, you can find data that are related to your research that you may want to reuse. So it will be the audience that you share your data with will be more targeted as well, which will again help you, or may other researchers help you find your data. I did a quick search on read3data.org and I found MPDS repository, Materials Platform for Data Science, which looked like it may be something relevant, but of course I'm originally a linguist, not a physicist, so you may want to check it yourself and see if you find anything that may be useful to you. If you don't find any relevant subject-specific repository, you may want to use institutional repositories as well, if there are some. I'm not including it in the list in particular because the Charles University does not have an institutional repository yet. We'll see whether there will be any or not. But if there is an institutional repository, you may want to use that. If there is no subject-specific or institutional repository, then there's always a general-purpose repository like Zenodo or Figshare that generally accumulates all sorts of research data, regardless of a discipline, and these can be used as well. Alternatively, apart from data repository, you may also want to share your data via data journal. Data journals are generally peer-reviewed journals that publish papers describing data sets that are made available via a repository. So you still, even if you publish your data in a data journal, you will need to make them public via a repository. An example is a scientific data. We will have a look at this particular journal briefly in a while. Sharing data sets in a data journal, so usually you wouldn't share things like a spreadsheet accompanying your published article. Usually you would use that for larger data sets that may be, for example, if you've got some measurements, like large measurements of some particular substance that may be relevant for other people that they may want to do research on, then you would then you may take this large data set and publish it in a data journal. In a data journal, you would usually only describe the data. You don't do any analysis on the data. You just describe what the data is about, what people can find in your data set. You also share the methodology of how you found the data, how you gathered the data or generated the data, so that other people know exactly what method was used, which particular tool you used, which particular script you used, or software, which version of a software. So there needs to be quite a detailed description so that other people know exactly what the data is about. When you share the data in a repository, or even if you share it on your personal website, which is generally not the recommended option, you should choose an appropriate license for your data. A widely used license for this purpose is a Creative Commons or Open Data Commons. The license will generally tell people what they can or cannot do with your data set. So for example, you may want to share your data set under a CC BY license, Creative Commons Attribution, which will mean that people can do whatever they want with your data. They can use it, they can modify your data, they can share it again with someone else. But if they use your data, they will always have to cite you. So that's the BY. You can also use for Creative Commons, there are other conditions that you may want to attach to your data. For example, non-commercial use that will restrict people to use your data so basically they can't make money off of your data. It is generally not recommended to use the condition no derivative, because that means that they cannot modify your data. So they, for example, other researchers would not be allowed to use a subset of your data. So basically, if you attach that condition to your data set, the only thing that people will be able to do with your data will be pretty much just to replicate your results and check that if I use this data set and the script that you're sharing, I will reach the results that you publish in your paper. So it's generally not recommended to use this one, but obviously if you feel it is appropriate or necessary, you may do that. It is also recommended that you share documentation with the data. If you do it via a data journal, then obviously the data paper will be the documentation. But even if it's only in the repository, you should still document your data. So publish any script that you've analyzed with your data, description of what the data means, what was the context of the data, when, how, and where you collected the data. You may also want to attach any code books or spreadsheets that describes what the data means, just so other people will be able to reuse your data and understand what it means. And finally, we will have a look at the journal Scientific Data, which is a journal published by Nature, and it is a peer-reviewed open access journal for descriptions of scientifically valuable data sets. The reviewers in this journal are generally asked to evaluate the rigor and quality of the experiments that were used to generate the data and the completeness of the data set, because obviously they weren't with you when you collected the data, so they can't tell if you did it the right way. But if they read the description, they can see, okay, I understood what the person did and I could possibly recreate it, or I know exactly how the data were collected. The journal publishes multiple types of papers. There are some meta-analysis or some commentaries, but the type of publication that is of interest to us is a data descriptor. Sometimes this type of paper may be called a data paper as well, but the term that they use is a data descriptor, which is a type of publication that provides detailed descriptions of the research data set. And it includes the methods that were used to collect the data and technical analysis supporting the quality of the measurements. The main elements of a data descriptor are, of course, the title, abstract, as you're used to, background and summary, so some small context that will context of the research where you collected the data. Why did you gather the data? Why did you collect or generate this kind of data? Why should it be useful and relevant to anyone? Then it should describe the methods, how you did that. There should be some data records as well. Technical validation, what you did to ensure the quality of the data that you generated. There may be usage notes or code availability, and of course references as you used in the normal publication. It can be used for big or small data. There can be data from new experiments or value-added aggregations of existing data. So, for example, if there are smaller data sets that were shared in multiple sources, then you can put them together. But at this point, you need to add some value to it. You can't just, compile the data sets together and say, here it is, I've compiled the data sets. It's not enough. You need to add something more. The data can be from major consortiums or single labs, depending again what you do and what you think will be relevant to people. The focus of the data descriptors is on helping others reuse the data rather than testing a hypothesis. So you're not expected, as you would in a research article, you're not expected to come up with a hypothesis and test it with your data. The data descriptor only describes the data set and the methods that were used. There may be, of course, if you have some hypothesis on your data, it may be published in an accompanying publication, but it shouldn't be part of the data descriptor as such. Usually it should not be a problem because we talk about new experiments and new data that were not published before. But usually it should not be a problem to submit a data descriptor while a related publication is under review elsewhere. But it might be a good idea to check with the editors of that journal to make sure that there is no conflict, because usually you would be required to check a box that you haven't submitted your research elsewhere. So just check with the editor that it is okay to have or to submit a data paper in another journal, and that there is no conflict. The actual data that you describe should be stored in one or more public community recognized repositories. Again, we talked about the re3 data where you can find some subject-specific repositories. If there is no choice, you can't find anything else, you can put it in Zenodo or Figshare to have it published, have it openly published. The journal itself, Scientific Data, has a list of recommended repositories that you can check and see if there is anything relevant to you, because the journal itself doesn't store your data, so it has to be stored elsewhere. The release of the data is a condition for publication. So when we talked about journal publications, when they may want you to share your data, share your underlying data, then there may be an embargo. In a data journal, in data descriptor, this is usually not the case, because that would be there would be like no purpose sharing a data descriptor if the data that you describe are not available. So that is a condition for publication. So that was the Scientific Data Journal.